Alright, so in this video, I just want to go through a quick summary of how we do problems that involve area between curves. There's lots of different things that can happen, the problems really vary in difficulty, but I just want to give a short summary of the basic process we follow each time and walk through an example. So we really have two cases typically. As I said, it could get more complicated, but typically we either have a situation where we have a clear function above and below, or we have a clear function on the right and the left. So I'll use f as the above or the right function, and g as the bottom or the left function. And when we do this, we usually look on an interval. So let's say for the first graph, we're looking from a to b, and this is on the x-axis. And then on the second graph, we're looking from a to b, but on the y-axis. And we're trying to find the area between these two curves. So when we do this, we're going to set up an integral. That's our whole goal, is to calculate this area using tiny little infinitesimally small rectangles that we add up using an integral. And so for the first case, we're going to use the integral from a to b of f of x minus g of x dx. So here we use x as our variable because our bounds are going from x equals a to x equals b. Additionally, our functions should be functions of x, so we should have a function that has x as the variable for f, and g with x as the variable for that other function. So this is what you would use if there's a clear example of an above and a below function, and it's often the case too that you have the x as the variable more easily rather than using y as the variable. Then in the second case, we would have something really similar, but instead we're going to do the integral from a to b of f of y minus g of y dy. So here we use y as the variable because our bounds are y values. We go from y equals a to y equals b. So to talk through this in a specific example, I'm just going to take a question from my online homework that I give in my classes. So this one turns out to have some yucky numbers, some yucky fractions, but I think it's a good example of just the basic process we follow each time, and it's the first problem on the homework, so I'm going to start with that. So my basic process anytime I'm asked to find the area of a region that's enclosed by two functions is to first decide if I'm going to use dx or dy. So do I have a clear above and below function, or do I have a right and a left function? Then after I've done that, I'm going to set up the integral. And lastly, I will just evaluate the integral. So the hope is that at this point, the evaluating of the integral isn't too complicated, and the new part is the steps 1 and maybe 2. So I like to always graph the functions that I'm given to really get a sense of the area I'm trying to find. Also, because we weren't given any bounds, we're going to need to figure out what the bounds are, like where these two functions intersect, and in some cases maybe they don't intersect, and then someone asked you a bad question since they want to know the area and there's no bounds on it. So if I go ahead and graph this here, I have 7x, which is a linear function, and then I have 9x squared, which is a quadratic function. So I can see here that I have the 7x, which is in blue here, as the top or the above function, and 9x squared, which is the orange function here, as the below. And I can think about adding these little vertical bars up from the left all the way to the right that span this whole area, with the top part of the rectangle as the above function and the bottom part of the rectangle as the below function. So these are functions of x. We have y equals 7x, so x is the variable, and y equals 9x squared, where x is the variable. And so this is going to align with our idea of using dx. So we have the above and below for dx, and we already have everything as y equals, which is also good for dx. So this tells me I'm on the right track, and it's not going to be too hard to set this up because it's already as I wanted. Just to note, we really could use dy here if we wanted to, so we could look at maybe horizontal rectangles with 9x squared as the right function and 7x as the left function, but when we do this, we'd have to solve for x. So we'd have x equals y over 7, and x equals the square root of y over 9. And that just looks a little gunky. That doesn't look very easy to me. I mean, you could totally do it, and if you want, you could try this problem with that and make sure you get the same answer. But I like to just keep things as they are, keep it simple if at all possible. But I just want to acknowledge that you really could do it both ways. Then the last thing we're going to need is the bounds on the integral. So where is this region enclosed by? Since we're doing dx, I want to look at the x components here. So I see x equals 0 is going to be my a, and then x equals 0.778 is going to be my b. Now I'm getting the sense that the b value is probably a fraction of some sort that's just been rounded by the computer, and so I'm going to find that exact fraction later on, but I could also just use that decimal really if you wanted, so I'll keep that for now. Okay, so we have figured out step 1. We're going to use dx as our variable, or we're going to use x as our variable, which means integrating with respect to x, and now we just need to set up the integral and then evaluate. So for my bounds, I'm looking at the integral from 0 to 0.778, and I'm taking the above function, 7x, and subtracting the below function, 9x squared. And this is an integral with respect to x. So I'd like to replace that upper bound with a fraction just to be more accurate, and we could have found this to begin with if we did this all by hand. I decided to graph the functions using a computer, but you could have graphed them by hand and then found those points where they intersect by hand. And the way we do that is by setting them equal. So I'm going to set 7x equal to 9x squared to figure out their intersection points. I'm going to subtract the 7x over to the other side in order to simplify. Then I'll factor out an x. And so I'm left with x times 9x minus 7. Now I can set each of these equal to 0. So I have x equals 0 and 9x minus 7 equals 0. Simplifying that second part, I'm getting x equals 7 over 9. So this is telling me my intersection points are 0 and 7 over 9. And if you check, doing 7 divided by 9 gives you that decimal that we had, that 0.778, so that's my fraction. Honestly, I think you might get this problem right if you just use the decimal, but I like to show you the more specific way to do it anyway. Also, I think we tend to get a little afraid of fractions, and practicing them when you can is going to make it way easier and less scary. Okay, so we've set up the integral, and our last step is to evaluate. So solving this integral isn't going to be too bad. There's going to be maybe some ugly math with these fractions, but doing the antiderivative isn't too hard. So I add 1 to the exponent and divide by the new exponent for both of these. So I have 7 over 2x squared minus 9 over 3x cubed, and I'm evaluating from x equals 0 to x equals 7 over 9. That 9 over 3 is going to just become 3, which is going to make things a little easier. So I substitute in 7 over 9, and then I substitute in 0. I'm not going to say that all out because there's just a lot happening here. So what we have here is really now just like a complicated computation or algebraic problem of simplifying this and making it look nice. So if you're working on the online homework and you just kind of want to get the answer done, you could just type this whole thing into a calculator and get a decimal answer and type that in. It should accept that, but I'm kind of picky. I like to get the fraction at the very end, and the answer is going to show you a fraction in most cases, I think. And so it's good to just get there, and since I'm showing you, I'm demonstrating, I'll go through that process. I used a calculator to help me with some of these computations. If I'm being honest, I actually just asked the Alexa in the room how to do some of this math for me so that I didn't have to type or stop recording. But here we go. So 7 over 9 squared is going to be 49 over 81, and 7 over 9 cubed is going to be 343 over 729. Then, because 0 is my lower bound, the second term goes away, so it's just minus 0. Now I'm just left with trying to make this fraction into something that maybe combines or looks a little better. So when I multiply the first fraction, I'm getting 343 over 162. And then I noticed that 729 is divisible by 3. You can check if a number is divisible by 3 by adding up the digits. So 7 plus 2 is 9, and 9 plus 9 is 18. 18 is divisible by 3, so I asked my Alexa how to do 729 divided by 3, and she told me 243. So I have 343 over 162 minus 343 over 243. Oof. And I had Alexa just combine those together for me, and I got 343 over 486. So that's a really disgusting fraction, I know, but it's kind of nice to get there and know that's the exact solution. We didn't have to round it all. But you could also get a decimal answer for this. I got 0.706 with rounding to 3 decimal places. So then we should be able to go to our question and type in that answer, and I'm seeing that it works. And if I check the solution, I get that yucky fraction I was talking about, that 343 over 486. Okay, so I know that last bit is a lot of algebra and a lot of math to kind of do computation, and so I think you should really be focusing on the new stuff, the graphing of the functions, and then figuring out if you're doing above or below, or right or left, and then finding those intersection points. And honestly, if you want to use some tools to help you solve those integrals, I totally support it. But this is also a good place to challenge yourself if you want to really work on your fractions, work on how to do things. But if you're really struggling to get the answers right, try to use some technology to help you out, or reach out to me and I can help you. Okay, so just remember, as a little review, our process is to decide if we're using dx or dy. These are the formulas that we have to use. Then we just need to set up the integral, and we evaluate. And this is the process I use anytime I'm given a situation where I have to find the area between two curves. Okay, hopefully that helps out a little bit with the material about finding the area between two curves. Thanks so much for watching, and I will talk to you in the next one.